This is my final project for Linux software development. It is a port of my C++ game engine Vixen that was written initially for Windows. It's only been tested on Ubuntu. Here are the dependencies. So it depends on SDL2, TinyXML2, Bullet, Physics, async, which is the open asset import library, libarchive, which is a compressed file read-write library, so for writing zips or tars, etc. gzips. libfreeimage is a image decoding library. glue is the OpenGL extension wrangler library. Port audio 19 is the port audio, the most current port audio library, which is used for decoding and streaming audio to the audio devices. libsoundfile1 is the audio decoding library I'm using. All those dependencies are needed to be installed on your computer in order to build Vixen and the test project. Now, here are the build instructions inside this repository. If you pull it or clone it, there's a project directory which includes a makefile, and that makefile should be able to be used to just make the test project. Here are the make commands to build a vtest application. Generally, you'd use all local, which will just build all the library dependencies, vcore, these library dependencies, not these. It'll build vcore, vaudio, vgraphics, and vgame all to the user local lib. You may need to actually have your library path environment variable set to include this directory, so that when I run make, this directory is, or when you run make, this directory is actually assumed as part of the library include path. After you do all that, there are some issues that you might run into with the makefile. Currently, it assumes it was written for my computer, which I have NVIDIA Bumblebee as my driver, OpenGL driver, so I switched the libraries that I linked to for OpenGL and the utility. So you might, if you don't already have NVIDIA Bumblebee drivers on your Ubuntu machine, then you might need to change that path or remove it completely inside the makefile. Now, to show you an example of where I'm talking about, it's basically right here. I look in user lib64 for NVIDIA Bumblebee in both of those locations, and this path might not actually be valid on your machine. Well, once you figure all of that out, you would come in here and you cd into the project directory, and you would make all local. Now this will run through and build each of the libraries that the project links to, as well as the project itself. It'll take a bit because it's a lot of source files, as you can see. Okay, now that that's done, we can run it. And what you should see is this, which is basically just a bunch of balls falling under gravity, so influence of actual physics, this floor model, and a first-person camera that you can walk around. So this project that I threw together really is an example of each of the systems that I've really spent most of my time this semester working on. When I came in the beginning beginning of semester, I really only had the font rendering, and that was about it. I didn't have any 3D graphics. I didn't have audio. None of that was really developed. So neither on Windows as well. So this semester I spent trying to implement those systems on Windows and then also porting them to Linux at the same time. The reason I implemented them on Windows first is because I was actually using this game engine in other classes as well, such as my data structures and algorithms class and my game design class. So there were multiple team projects that I worked on that they utilized this game engine. Balls keep bouncing. There's also a camera change that you can do, which if you hit function 6 key, you can actually change to a freeform camera, so you can fly around and look at stuff a little bit better. So there's a ball bouncing. You can also go through the floor and look at underneath. So in addition to the model rendering, fonts, 3D camera, physics, there was also audio. Now I can show you the how the audio works. It takes a little second to set up though. So I'm going to pause the game by hitting function F3. And I'm going to change, and we're going to hear some audio. Okay, so there you go. That was some of the audio playing. Basically, if you want to play audio, it's well, it will be here. And oh no, so there's an issue with the ALSA audio. It actually cripples the frame rate, either due to some sort of memory leak or something that I haven't really discovered yet. But I'm going to rerun the application. But what I was saying is that if you want to run audio, which will be on, the controls will be on screen for when you actually run this yourself, but it's function F4, and then to pause it, you just hit P, the P key. So as you can see, we have audio, model rendering, physics, UI. Those were really the systems I was trying to develop. If I look at what I said in the initial roadmap that I gave for what I was going to develop, the project proposal, the beginning work was supposed to be done on the resource management system. Now, I chose to not actually focus on that due to the complexity of the other systems that I wanted to develop, such as physics and model loading and audio playback, and the rendering, and especially since setting this all up on Linux was actually quite complicated. Visual Studio on Windows generally is a very, very good development platform, as it handles a lot of the it's very intuitive how to link libraries, but I'll actually show how I was able to get around that on Linux, and what I used to develop. But I think that for the most part I hit everything that I wanted to. I was able to get a Linux machine up and running that I could actually develop on, and see my projects that I originally was only developing on Windows actually run and work on in a Linux environment. So enough about that. Let's actually look at you can also go full screen, by the way. Let's look at the code. So when we close that, I'm going to actually close this project. So here are this is actually how I was developing. I set up some code blocks projects that would help with the linking of libraries, because code blocks actually lets you set up the paths, and it basically has its own make file that'll generate for you, which helps a lot. Handwriting a make file when you have large numbers of library projects gets a little bit dicey. So let me explain each of these libraries. vCore is basically the platform independence layer, sort of the lowest layer of the engine. It really just has utility functions for different platforms. An example of this would be if we go into OSUtil. So this is where I have some functions that are operating system specific, have operating system specific implementations. So as you can see, I have a lot of these if-defs thrown around that are compiler flags for when I'm compiling on Windows or Linux, or Unix for that matter. So as you can see, I have some, so this function would check if a directory exists. Now on Windows you have to use get file attributes and then check the attribute dword against, whether basically these bit flags. On Linux you just have a struct, stat struct, and then you just read that in, and then you can check if it's directory. It's a lot easier, I think, a lot simpler, but this will actually return the directory, so it'll basically give you the parent directory of a path or a file. This is an interesting function. This is actually used so that when I run an application as a process of another application, generally the assets were loaded from the executable directory, so where the application was executed. But if you execute as a process from another application, that changes, or it's not really the same. It's not right next to the application. So this function will actually get the path to the executable where it's actually running. So on Windows, it's pretty simple. You just get the module file name. But on Linux, you have to actually get. It's a little bit strange, but you have to do this. So here are some examples of where I had to do platform-specific implementations. So that's vCore. I think that's sort of been explained. So with graphics, well, let's go into audio. Actually, audio is kind of fun. So with audio, what I did was I created sort of this wrapper around port audio. So here are a bunch of utility functions, and then inside, so here are the implementations. It's very, very basic at the moment. It just has functionality for querying each device, opening a default stream, closing a stream, sleeping, printing out devices. The audio manager class is actually used to load the sound data. So here's where it's loading in the sound file. It's playing a sound file, so it opens a stream, and then it starts the stream, stop, aborts it, terminate. Sound file is actually it's very small, but it just has the utility function to read data. So this uses libsound file and will open the decode a sound file. So pretty much any open format, so no proprietary formats such as MP3s can be read. I believe it does have potentially support for MP3s, but there's licensing issues, so generally you want to avoid that. So that's audio. Now graphics is the largest library by far. As you can see, it has quite a few CPP files. So let's look at model, for instance. So here's an example of where I used async. So async, here I'll load in, I'll pass in the file path of the model. Async will load it if it can. If it can, it'll just say error. And then I get all the information. So I'll build the vertex lists and index buffers, and then for use for passing to OpenGL. So then I'll render it. Here's my free image utilities, but let's look at GL texture. So here's the texture class, a basic texture class that will use free image to load an image. It'll get the width and height, and then it'll take all the image data that it loaded into here, and it'll pass it into right at the end of this when I'm generating the actual OpenGL image. Yeah, and here's the font. So BM font stands for bitmap font, and there's actually a tool on Windows called BM font generator or BM font file. I don't know, it's one of the two, but it's developed by Angel Code, I think, which is a website, and it basically will take installed fonts on Windows and build bitmap images. So that's how actually here I'm rendering that the text up here. This text is actually a bitmap image, and it will render. It'll find out the dimensions of each glyph, each character glyph, and will render based on a source rectangle of that size. It'll render each character. So that's why it's useful to have this integrated with the texture batcher, because rendering each character, each image over and over again would get probably a little bit, it'll take a toll on performance, just put it that way. Let's go back here. So that's generally graphics. I mean, you can look through the rest of the code. Those are sort of the highlights. Vgame is the most top level library. This is where the actual SDL window is. So here's, of course, the SDL window class. Bunch of utilities, trap cursor center, which is used, to keep for an FPS camera. The mouse always has to be in the center, because then the movement's relative to the center of the window when you move the mouse. Toggle cursor, of course, is used when I'm hitting F3 to go in and out of FPS and paused mode. There's init, where I generate a bunch of stuff. As you can see, this application requires that you use have at least 3.3, OpenGL version 3.3. If you don't have that on your machine, then you can't actually run my application, unfortunately. It uses modern OpenGL. Here's the main application loop. This is really where everything happens. So I call the onStartup function, which we'll see in a second. I loop. So here's the application loop. I handle some basic input stuff. This is like some top level input. I tick our game timer, and then I start rendering. So I clear, I call update, I call render, I update the input with the previous, and then I swap buffers, and I calculate frames per second. And then if we ever break out of the main loop, I call shutdown, which will clean up memory. So here's some more useful functions that I'm still implementing as well. But the goal with this actually continue moving on from this class is actually to abstract the engine even more, so that I can actually interface a DirectX renderer and an OpenGL renderer. Currently it's very kind of OpenGL specific at the moment. But yeah, here's the content manager. This class actually just manages loading fonts and textures, so that if you try and load the same texture, it'll just return to you the same texture, pointer to the same texture, because there's no sense in loading the same texture twice. Same thing with fonts. So, and here's the game class. It's basically an abstract class. This is implemented in the main function that the user writes. So it's very bare bones, but it does have this run function, which is called in main, and it starts the game basically. Game config is interesting, and we'll actually look at that for a second. The config file actually is an XML file that has some attributes such as the width and height, title, and position, which is useful so that you can actually change or set the size that the user wants to play the game at without having to recompile the application, because that would be kind of dumb. So let's look at that actually. So inside assets, so you'll find that there's a vtest config. So let's edit that. So currently it's set to have this title, Linux Software Development, so we can change that just to say Vixen, and we can also change the height to be 800 by, let's say 800 by 600. So now if we run, it's now much smaller, and our title of our window has changed. So when the application is run, it loads that config file first and then sets all the data on the window based on that, which is useful. So that's the config. Let's look at the actual main file now. Let's cd into source, and let's edit for a moment, or look at this. So this is where everything is happening, really. Everything that you see on screen, it's in one main file. It's actually very small too. There isn't too much going on. So here's where the game config is loaded. Here's assets vtest config, and then I pass in the config and run the game. Now what happens when the game runs? Now what'll happen is it'll call on startup, and here's where I create the font, the model for the floor, the bullet physics simulator, the audio manager, every dodgeball, all the dodgeballs that are falling, I just loop over about 10 times. It creates 10 of them. I create both the dodgeball model and the corresponding rigid body for each. Then I create the floor rigid body. I create the FPS controller, which is essentially just the camera. There is a physics-enabled version of the FPS controller, but I disabled that for this test. I clear the back buffer. I set the clear color of the back buffer to cornflower blue, which is that nice blue that you see, and I set the camera position, and then I set the window to not have the cursor show. And then on update, this is what's called every frame. Here's where I handle the basic function key inputs. So F1 sets it to full screen, F2 closes it, F3 does the basically pauses the game and allows you to edit stuff outside. F4 plays, tells the audio manager to play sound, and then P, the P character, will just stop the audio manager. And then if you're not playing, I return because I don't want to update, but in here F5 and F6 will change the camera type, and then the rest of it is just updating the physics simulation, updating the character controller, having the camera rotate, updating the camera so the camera's position updates accordingly, and the basically projection and view is recalculated. And then I move all the dodgeballs so that they transform based on the physics rigid body. And finally, I trap the mouse cursor to the center, because if I don't do that, then the camera won't actually rotate correctly, because it'll be too much of a difference in movement. It really needs to be a slight difference. On render is where everything gets rendered, so the model, which is the floor, actually, every ball gets rendered, and then camera debug statistics, which is all the UI that you saw on screen, as well as the frames per second. Here I just delete some stuff such as the rigid body, the floor body, the audio manager terminates, and I delete the audio manager. And that's about it for this for that main file. So let me close this. Let's run it again. Got to be in the directory. So all of that which I just went over is pretty much everything you see here. That's the power of object-oriented programming. I mean, there's quite a bit of code that's behind this, but the main file is quite small comparatively. So that's the project. I hope you like it. I mean, it was very fun to try and port my Windows code to Linux, and for the most part, since I stuck to using only cross-platform libraries, everything worked pretty well, which I guess is a testament to how well those libraries were developed as well. So thanks for watching. Let me know if you have any questions about the test project or any troubles, and thanks.